All right, so we are going to look at exponents. Pretty simple, pretty basic. So it says, write and evaluate numerical expressions involving whole number exponents. So numerical expressions, so no letters will be involved, only numbers. All right, and an exponent is when you have like a number and a little tiny number up there. That's what an exponent is. Okay? So it says Brianne needs to contact members of the softball league. She calls 4 members in the morning. Those 4 people each call 4 more people in the afternoon. And that evening, those additional 4 call 4 others. How many people are called that evening? So anybody have any idea of how would we solve this? Any thoughts?
I feel like how we would solve this is that we would have to call, we would have to like add up.
Okay, add what up?
We have to add all the members up and then subtract what has been in the evening.
Okay, so you mean add 4 plus 4 plus 4 plus 4?
Hmm?
You couldn't do that because it said who called that evening.
Right, so we do need who got called in the evening. That is correct. Give me one. I'm trying to finish attendance real quick. Give me one. So Peyton and Kylie. Okay, so kinda, but we're not really going to add. So let's start with a little factor tree. All right, so this is Brianne, right? So my first person. And Brianne calls 4 people. So this would be the morning, right? So in the morning, she calls 4. So these 4 people call how many people?
4 other people.
They call 4 other people. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So that would be afternoon. So how many people were talked to in the afternoon? So 4, 8, 12, 15. Is that right? So 15 people were called in the afternoon. And then these 4 people also called 4 more people, right? So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So that would be 4, 8, 12, 15, right? So I'm not going to draw each one of these, but we know that this would be 15, this would be 15, this would be 15, this would be 15, and that would be 15. So 1, 2, 3, 4, 5. So 15 times 5. And what does that give me?
Hold on, can you give me a minute?
Yep.
$75, I think.
Yeah, 75. Something's not right though. Hold on, what did I do wrong? So 4 should have 16. How did I get 15? Hold on. So if we did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I didn't add very right, did I? We should have 16 in the afternoon. And then what would we have here? 4, 8, 9, 10, 11, 12, 13, 14, 15, 16 I didn't add right, did I? So we should have 16 here. So 16 times 5. So what's 16 times 5? Yeah, something's still not right. I'm not doing something right. Let me I'm going to redraw these real quick. Because I kind of crammed it all in one little location. So let me do up here. So Brian. So 1, 2, 3, 4. Okay, so the morning was 4. And then from here we did 1, 2, 3, 4. Okay, so 4 times 4 was 16. Alright, and then from here, we're going to draw 4, 4, 4, and 4. I think that makes it a little bit easier, right? So all of this would give me 16. So I don't know what I did up here, but we only have how many of those? 1, 2, 3, 4, not 5. So we would have 16 times 4, which is 64. So in the morning, you see it now, Peyton?
Yeah, because I was about to say it was 64 now that you...
Yeah, now that I did it correctly. So in the morning it was 4, in the afternoon it was 16, and in the evening, which is what they asked for, right? Can't spell today. So in the evening, we had 64 people. If they wanted to know the total, so if, they didn't ask us for the total, but if we wanted to know it, then we would add the 4, the 16, and the 64. And that gives me 84. All right, makes sense?
Yes, ma'am.
Okay, do I need any more time to copy?
I'm done.
All right, awesome. All right. Somebody, Kylie says, can I have a minute? Yes, you can. All right, is that you telling me you're good? So remember, Kylie, I went back and changed that. It's not 15, it's 16. Oh, you said, okay, I'm done. All right. So let's flip it over. All right, so it says, a small company uses a phone tree to notify employees of cancellation due to bad weather. The manager calls 2 people. Then each of those people calls 2 more people, and so on. Okay? All right, so the first round, so that first person calls 2 people. The second round, those 2 people call 2 people. The third round would be 2 times 2 times 2.
2.
Yep. So what would my fourth round look like?
2 times 2 times 2 times 2.
Yep. And then my fifth round would be 2 times 2 times...
Times 2
Yep.
times 2 times 2.
Yep. All right. So it says, complete the table. What patterns do we see? So what is my pattern? What do you notice?
Every time you multiply, there's sorry, every time you multiply, it's always 2. And
Yes.
it never changes to a different number.
Yep, so each round we are adding a multiple of 2. So we had one here, then in round 2 we're adding 2, round 3 we added another one, round 4 we added another one, and round 5 we added another one. Okay, so when we talk about exponents, right, the whole number is called the base, and the exponent is that little tiny number. So that's the base and the exponent. Okay? All right, so we're going to complete this statement. So in the second round of calling, the total number of calls in that round was the product of 2 2s. So second round, 2 times 2. In the third round, it is a product of how many? How many 2s do I have? 1, 2,
3.
yep. So it is the product of 3. In the fourth round, it's a product of how many?
4.
Yep. And in the fifth round, it's a product of?
5.
Yep. All right, so how is the number of round of calling related to the number times 2 is used as a factor? So if you notice, first round, how many 2s do we have?
1.
Yep. Second round, how many 2s do we have?
2.
Yep. Third round, how many 3s do we have? I mean, how many 2s?
3.
Yeah, we have 3. So each round is the same for the number of 2s we multiply.
Oh, I had a question.
Uh-huh.
Since I'll be coming back to school in January, am I getting like a new schedule?
Yes.
Okay, because I didn't know when I was supposed to get it.
You'll get it the first day you come.
Okay.
All right. So when is it useful to write an expression using a base and an exponent? So let's think about that. So if I just had 2, would it make sense for me to use an exponent?
No.
No. What if I had 2 times 2?
I think, yes.
You could, but it really wouldn't make, you could say 2 squared, but we honestly wouldn't need it, right? Because 2 times 2 is 4. So what if I had 2 times 2 times 2 times 2 times 2 times 2?
Then yes.
Yeah, definitely, right? Because this would be 2 to the 1, 2, 3, 4, 5, 6, 7. 2 to the 7. Okay? So guys, also notice that when we have an exponent, it does not mean 2 times 7. Okay? So it does not mean 2 times 7. It means 2 times 2 times 2 times 2 7 times. So multiply 2 7 times. That's what that means. Okay? Any questions on that?
No, ma'am.
All right. So let's look at this one. So it says a dot is sometimes used instead of the symbol X. Remember, I've been saying we need to get rid of using X's for multiplication because they look like a variable. So it says you can use an exponent and a base to show repeated multiplication of a factor. The expression shown is read 7 to the 5th power. So 1, 2, 3, 4, 5. So 7 is the base, 5 is the exponent, and it is read 7 to the 5th power. We have 2 that have special names. So 8 to the 2nd power can also be said as 8 squared. And anything to the 3rd power, so for example 9 to the 3rd power, could be 9 cubed. So if I had 2 to the 3rd, it would be 2 cubed. If I had 2 to the 2nd, it would be 2 squared. Okay? Oh, that was backwards, wasn't it? That should be a D. All right, so it says an exponent tells how many times a number is used in an expression. So look at the expression. 5 times 5 times 5 times 5. How many times is 5 a factor?
4.
Yep. All right, so we're going to complete each statement. So 1, 2, 3, 4 becomes 5 to the what power?
The 4th power.
And 8 times 8 times 8 times 8 times 8 is 8 to the what power?
To the 5th power.
Yep, to the 5th power. Exactly. All right, so write an equivalent repeated multiplication expression. So 2 to the 3rd power could be written as?
3 2s.
Yep, 2 times 2 times 2. 1/3 to the 5th power can be written as what?
5 1/3.
Yep, so 1/3 times 1/3 times 1/3 times 1/3 times 1/3. All right, so the last one says find the value. So if it says find the value, or if it says evaluate, then that means you're going to multiply them together. So you're going to tell me what is 5 times 5 times 5. So what is 5 times 5 times 5? Well, 5 times 5 is 25. Times 5 again would be what?
125.
Yes, 125. Remember, it's not 5 times 3. The answer is not 15. It means you are multiplying it out. Okay? So what would 4 times 4 times 4 times 4 times 4 equal? So how would we do that? So 4 times 4 is 16. And then you can either say 16 times 4, or I could do 4 times 4 again, which is 16. So then I could do 16 times 16, get my answer, and then multiply that times 4. Or I could just say, what is 16 times 4? Get my answer, right? And then do that answer times 4, get that answer, and then multiply it times 4 again. Doesn't matter. So let's do the 16 times 16 and then times the 4. So 6 times 6 is?
36. 6.
Yep. Carry the 3. 1 times 6 is
6.
plus 3.
9.
Yep. There's my placeholder. So 1 times 6.
6.
Yep. And 1 times 1. All right. So we get 6 and x is 6. I can put a 0 there too. 9 plus 6.
15.
Yep. And then 1 plus 1.
2.
2. All right. We still got the 1 4, right? So 256 times 4. So 6 times 4.
24.
Yep. 5 times 4 is 20 plus 2.
22.
Yep. 2 times 4 is 8. Plus 2, 10. So 4 to the 5th power is 1024. 1024. All right, so let's look at the check for understanding. Let's get through that, and then I'm going to release you to do the on your own. So it says a farming community begins with 1 resident. Then every year the number of residents multiplies by 10. Write an expression using an exponent to represent the number of residents in the community after 5 years. So what would my exponent be? 10 to the what?
To the 5th power.
Yep, to the 5th power. It doesn't ask me to evaluate. All it asks for is an expression. All right, number 2. On a tree, the trunk splits into 5 branches. Then each branch splits to 5 more, and then it splits to 5 more. So this would be 5 to the what power?
To the 3rd power.
Yep, because we have 1, 2, 3. It says how many very thin branches are on the tree. So it wants me to figure out what is 5 times 5 times 5. And we already know that one, right? Because we did it earlier. Didn't we do it?
25.
Yeah, didn't we do it earlier? So that would be 125. All right? All right, so 2 to the 10th. So the number blank is used as a repeated factor blank time. So what are we going to put in there?
The number 10 is used as a repeated factor. Wait, 2 as a repeated factor 10 times.
Yep. All right, so what is the base of 2 to the 10th power? What's my base?
2.
Yep. What's my exponent?
10.
Okay, and then what is the value? So that means we're going to evaluate. So 2 times 2 times 2 times 2. 10 times, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we could probably break it down, right? So 2 times 2 would be 4. 2 times 2 is 4. So then we could do these, right? So 4 times 4, that would be 16. So we already used this one, so we're not going to do this 4 times that. We're going to do this one, which is 16. So we already know this one, right? 16 times 16 and then times 4. Didn't we do that one earlier? Up here? So that would equal what?
1,024.
Yep, 1,024. Okay? Alright, so the on your own is only a 1-pager. Shouldn't take you very long. Alright, if you need help, I am here. I am logged in. Just let me know what you need help on. Okay? You are doing all of them. Oh, sorry. This is on your own. My bad. But you are going to do all of them, okay? If you need help, let me know.